Now we may have to zoom out a little bit on this one, but and this is the neat thing I saw from Steven Storgatz's tweet. You said in the beginning there were a couple shapes you knew how to find the area of. You said squares and rectangles were one, but there's another shape you said you knew how to find. Triangles. You knew how to find the area of. So instead of a rectangle, my challenge to you is to see if you can rearrange these pieces into something that looks like a triangle instead of a rectangle.
I have an idea here.
And what I'm going to do, maybe we should just do this on the table. Can you kind of sweep up the 16? And that way, maybe I can zoom out enough to make it to see the whole thing.
So
Yeah, a good thing to use as the base would be this line down here.
So we can line up something like this. This isn't all of them, but this makes a triangle.
Oh, interesting.
And now we have, this takes 4. If we put 4 of them together, we can probably get a bigger triangle.
Add them up. And then we keep sticking pieces on. And then you'd have one up there. And then this one goes
last piece. So this is
Whoa.
a very tall triangle.
In fact, it is a very tall triangle, and I guess we have enough room. Maybe, can you just look in the viewfinder and tell me if it's sliding this in is okay? Does it fit?
Yes.
Yeah.
Okay. So we do have a very tall triangle. Can you remind me what the wow? I'm really glad that you guys found that triangle. I thought this was gonna take a while. Now, what is the formula for the area of a triangle? What do we have to do in an area of a triangle?
We have to calculate the base and the height.
Okay, and so what's the area formula?
1/2 base times height.
So the area is 1/2 the base times the height.
The height is approximately 4 radii.
Which is due diameter.
Okay, so the height is approximately 4 times the radius. So that's cool.
The base is 1/4 of the circumference.
Ah, so the base, which I'm going to call B, is 1/4 of the circumference. And what was the circumference?
It was pi times 2 radius.
Yeah. So 1/4 times 2 pi r. And can you tell me how that simplifies? 1/4 2 pi r.
Pi r over 2.
Very good. Pi r over 2. And so now we have the area is, we're sure hoping this is going to be pi r squared, right? Mm-hmm. Because you shouldn't be able to rearrange things and get different areas.
4r.
Well, let's not forget the 1/2.
1/2.
Yeah, 1/2.
Times pi r over 2.
Oh, sorry, yeah.
That's base first.
And we'll do, well, yeah. Pi r over 2. Times?
4r.
4r.
Well, you
have 4 here, and you have 4 up top.
So you can use the 4 to cancel out the fractions.
Yeah, and what am I left with once I do that?
Pi r times r, which is pi r squared.
Pi r squared. How about that? Now, as we chop up the circle into smaller and smaller ones of these, do you think?
You'd get more accurate.
And I think it would get taller too.
Yeah.
Get taller and slimmer until it would be just a line. Yeah.
Well, but if it were, I think that it would get, because you're chopping up into more of these, you're going to use more of these for the base, so it might actually get shorter and wider.
Yeah, it's actually a good puzzle. Is it going to get tall and thin or short and wide?
Well, I think it might actually just expand, because if you use more for the base, you have to use more for the height to get up to the height.
Uh-huh.
So it's going to get tall and wide.
Oh, interesting. So maybe it gets taller and wider.
Well, But why, if we chop this up, should it grow? Maybe it would have to stay the same area.
Ah, it has to stay the same area.
So it would have to cover the same space.
Well, not necessarily.
Well, it has to cover the same amount of space.
It has to cover the same amount of space. It doesn't have to necessarily convert it to this exact triangle, although maybe it does.
It just has to stay covering the same amount.
Yeah, so it's an interesting question to ponder. What's going to happen as you chop this up?
I-
Previously, our rectangle will stay the same.
So,
But if you use more for the base, but the pieces are thinner, it's going to stay the same. The base is going to stay the same length. And then the pieces will it stay the same?
Might stay, maybe it stays the same.
And
yeah.
you have the same angle going up, so it's going to have to end.
Ah, interesting. Now, when I chop those up, do I keep with the same angle?
well,
I think you get a taller, steeper angle.
Yeah, it looks like you're actually going to
Yeah.
get a taller, steeper angle. So it does seem like it's going to grow taller.
Taller.
And what does that mean about the base? What's going to happen to the base?
it's gonna get thinner.
The base has to get thinner. But I'll leave that for you guys to ponder. But that was a great thing to wonder about.
Yeah.
Okay, and then we're going to take a look at one more thing.
Alright.
Okay.